Hello, everybody. Firstly, I want to. Hello, everybody. Firstly, I want to thank Dr. Shree for giving me this opportunity to attend and participate in this conference. I think I'm the youngest one in the speakers, so please be kind with me in the questions. Okay.
Don't worry, you are the stage of fun. You are the smallest one and the newest one in the state.
I'll give you an introduction just to enlighten you about Geopolymer, its preparation and applications. So, what's Geopolymer? Geopolymer is an aluminosilicate-based inorganic polymer. It's formed by heterogeneous reaction between aluminosilicate solid source and concentrated alkaline solution. This reaction is called geopolymerization reaction, which is polycondensation polymerization. Note that aluminosilicate sources are the most abundant in the Earth's crust. That's why we call it geopolymer. Geopolymer has three basic forms, depending on silicon to aluminum ratio, namely polysialate, polysialate siloxane, polysialate disiloxane. This is sialate group, SiO-ALO, and this is siloxane group, SiO. So it's obvious that in polysialate, we have silicon to aluminum ratio equals 1. And in polysialate siloxane, we have silicon to aluminum ratio equals 2. And in polysialate disiloxane, we have silicon to aluminum ratio equals 3. If the ratio is greater than 3, then we have sialate link, which is cross-linked polymer. The microstructure of geopolymer is amorphous to semi-crystalline, that's temperature dependent. Geopolymer has a lot of advantages that make it suitable for a variety of applications. Generally, it has low manufacturing cost because of the simplicity of its preparation. It has good physical and mechanical properties. It also has some criteria that make it suitable for specific applications. The first and second criteria are low energy consumption and reduced greenhouse emissions. These two criteria make it a good replacement of Portland cement because in the calcination process of cement, the calcination of lime, it emits CO2, but the calcination of aluminosilicate source doesn't emit CO2. The third criteria is anti-corrosion, which make it can be used as storage for chemical. The fourth one is fireproof. So it can be used as fire and heat resistance coating. The fifth one is high porosity, which make it used as membrane. As I mentioned, we have solid source raw materials and liquid source raw materials. That's why we have heterogeneous reaction. The solid source includes clays like metakaolin and industrial waste, for example, ashes, slag, waste blast, copper mine tailing, rice husk, etc. Of course, metakaolin is more expensive than industrial waste, but it's preferred because it allows easy interpretation of results, because it doesn't contain impurities like industrial waste, so it's preferable for membrane preparation. Liquid source is called alkali activator. It includes alkali hydroxides and alkali silicates, but it's better to use mixture of both alkali hydroxide and silicates. The preparation technique consists of mainly two steps. The first one is mixing of solid and liquid raw material sources, and if we have additives, we will add it also to form binder. Then curing to consolidate this binder to form hard geopolymer. There are some additives added to the main raw materials to enhance some properties according to the application. So here in membrane preparation, we have main additives, hydrogen peroxide, which is a foaming agent that we added to enhance porosity. Zewail, which has double effect because it enhances the porosity because it has microporous structure, and it also increases the compressive strength if it has fine particles with small ratio. There are some factors affecting the properties of geopolymer. The first and the most important one is the pre-treatment of raw material. It's found that geopolymer produced from calcined raw materials show like metakaolin, ash, and slag shows better mechanical properties. Previously, they used kaolinite, but the geopolymer was weak, so it was calcined. Calcination also helps to improve the reactivity of raw materials, transforming it from crystalline phase into amorphous reactive phase. Also, during temperature and water content, in addition to the additive, can control the porosity and the pore size of the geopolymer. That's it. Thank you.
When you have the best, from my opinion, the best one, but you say everything very clear, quickly, but very clear. According to your question, I think لا هي بتسأل أنا برضه هي محمسة هي ده شباب بسم الله الرحمن الرحيم اتفضل. هو ماذا استخدام مصر يعني وصلنا كتير؟
ماذا استخدام جيوبوليمر وصلنا كتير؟
اوكي، هو المفروض ان هو حاجه حديثه، فيعني اصلا كل البيبرز بتاعته تقريبا ستارتنج من 2010، فمش يعني تقريبا 2010 يعني مش قديم قوي. مش عارف يعني اول بيبر مثلا.
هو هستخدم حضرتك بالنسبه لمصر جيوبوليمر هو دخل الحديث في الابحاث، وفكر بدايته في استخدامه كمواد بناء كبديل لمواد البناء وكطوب، بالاخص كطوب للبناء بدل من الطوب الاحمر اللي بيستخدم حاليا. وده احنا عملنا فيه ابحاث كتير ودخلنا منه استخدامات بعض المخلفات المصانع برضه دخل، وانشانا منه طوب بناء واعطى نتائج جوده مطابقه للمواصفات القياسيه المصريه والامريكيه في مقارنه بالطوب المستخدم حاليا اللي هو الطوب الاحمر. تمام؟ بالنسبه للممبرين هو لسه سيرش حديث بدا في سنه 2020 او 2019 المشروع في مستوى العالم على مستوى العالم، ولسه حديثا بنستخدم في كممبرين او كمواد ادزوربنت لبعض المواد الملوثات الموجوده في الميه. شكرا.